In this lesson, we're going to use the concept of expected value to analyze some games of chance. And in particular, we're going to focus on the idea of a fair game or an unfair game. So let's begin with an example. We've written an example out here. So suppose that you go to a casino and you find that they're offering the following game. It costs €1 to play, and you roll a die, and if it shows 1, 2, or 3, you get nothing back. If it shows a 4 or 5, you get €1 back, and if it shows a 6, then you get €3. So the question here is this a fair game? What do we mean by fair in this context? Well, what we mean is that in the long run, would you expect to win or lose if you played this game repeatedly? So the way that we're going to analyze this game is to calculate the expected value of the payout and then compare that with the cost of playing the game. So first of all, let's recall the formula for expected value. So remember that the expected value is the sum over all possible outcomes of the value of the outcome times the probability of the outcome. So in other words, we go through each outcome and we multiply its value times its probability, and we add up all those numbers, and what we get is called the expected value. Right, so the first thing we have to do here is list the outcomes. So that means writing down the sample space. So in this example, the sample space is all the possible outcomes that we can get when we roll a die. So here it is, it's the set 1, 2, 3, 4, 5, or 6. Now we want to calculate the expected value, so we need to work out the value of each of these outcomes and the probability of the outcome. So when we talk about the value of the outcome, what we mean is what payout does that outcome correspond to? We can use a table to help us do the calculation of expected value. So here's the table. In the first column, we're going to list all the outcomes. So the outcomes are 1, 2, 3, 4, 5, 6. And now in the second column, we'll list the value of each of these outcomes. So that's the payout that we get when this outcome comes up. So now remember that the payout for 1, 2, or 3 was 0. The payout for 4 or 5 was 1. And the payout for 6 is 3. And now in this column here, in the third column, we list the probabilities of each of the outcomes. So now when we roll a die, assuming that the die is fair, the outcomes are equally likely, so each of them has probability 1 over 6. So those are the probabilities of the outcomes. And now in the fourth column, we take the entry from the second column and multiply it by the corresponding entry from the third column. So value times probability. So here we get 0 times 1/6, which is 0. 0 times 1/6, which is 0. 0 times 1/6, again 0. Now here we have 1 times 1/6, which is 1/6. 1 times 1/6 is 1/6. And finally 3 times 1/6 is 3 over 6, which is a half. And now to calculate the expected value, we just take the entries in this column here and add them all up. So we have 0 plus 0 plus 0 plus 1/6 plus 1/6 plus a half, and that gives us 5/6. So we just add these up and we get 5 over 6, and that is the expected value. So what this means is the expected value of the payout in this game is 5/6 of €1. In other words, in the long run, if we play this game many, many times, on average, our payout will be 5/6 of €1 in each game. And now to decide whether or not the game is fair, we just have to compare that to the cost of playing the game. So remember that the cost of the game was €1. So this means in the long run, we pay €1 per game and we get back 5/6 of €1 per game. That is in the long run on average. So clearly this game is not fair. Clearly what's happening is that in the long run we expect to lose 1/6 of €1 per game. So we'd say that this game is unfair. In general, a fair game is one in which the expected winnings of each participant is 0. In other words, in the long run, each participant expects neither to win nor lose. And if a game is not fair, then we say it's an unfair game. Okay, let's look at another example. So here we have another game of chance, this time based on a deck of cards, and the rules are described here. You're playing this game with a friend, and if you draw a non-face card from the deck, you pay her €6, and if you draw a face card, she pays you X euro, where X is some unknown. And the question is, what should X be in order to make this a fair game? So what do we have to do? We have to calculate the expected value of your winnings and see what that is in terms of X. So the first step is to write down the possible outcomes, or to describe the sample space. So the sample space, in this case, well, there are various ways we can do it, and I think that probably the simplest way to do it here is to write down two outcomes. So the possible outcomes are either face card or not face card, because these are the outcomes that we have values associated to. Now these are not equally likely outcomes, so we need to work out the probabilities of each of these outcomes. So the probability of drawing a face card, so how many face cards are in a standard 52 card deck? Well, there are 3 face cards of each suit, so a total of 12 face cards in a 52 card deck. So that means the probability of drawing a face card is 12 over 52. And we can cancel off a 4 there, and that is 3 over 13. And the probability of drawing a non-face card, well, if there are 12 face cards, that means there are 40 non-face cards. So 40 over 52, which is the same as 10 over 13. So those are the probabilities of the outcomes. And now we write down the values. So the value of a face card is, and remember we're talking about the value to you, is X euros. So remember, if you draw a face card, she pays you X euro. The value of a non-face card, well, the rules were that if you draw a non-face card, you pay her €6. So it's minus 6 euros. So now what's the expected value? So the EV, we go through each outcome and we multiply the value by the probability. So we have X times 3 over 13 plus minus 6 times 10 over 13. And now if the game is fair, that has to be 0. So now you see we have an equation for X, and we should be able to solve this. So it's a simple linear equation in X. So we could start by multiplying by 13. So that would give us X times 3 plus minus 6 times 10 equals 0. If we multiply across by 13, and that's the same as 3x minus 60 equals 0. And now bring the 60 to the other side, we get 3x equals 60, and divide by 3 and we get x equals 20. So that means that in order for this game to be fair, she must pay you €20 for drawing a face card.